We're gonna go through these sort of quickly because I think we got through like most of them, but we're gonna go back through them. You guys will have to tell me if, you know, if we get something and you tell me, hey, we didn't really cover that, then that's fine. I mean, I'm gonna go back over everything. So binomial distributions. The binomial distribution, again, we're going to be doing stuff like this. You're going to have your x here, and you're going to have your probability of x. We're going to be building these charts. Sort of like a, what was the other ones that we've been doing all year long? Instead of frequency distribution chart. So sort of same idea. A lot of these, we'll have this, your x will be like 1, 2, 3, 4, 5, 6, whatever. And then you're going to put the probability of each of those things happening here. We did this last couple of sections. Then from that, we're going to, of course, make our histograms and so on, so on, so on, so on. The other thing, we're going to use the calculators on those charts that you got. It's the, if you look at it, we're on this actual second page, not the back of the first page, but the second page. It says binomial distributions, and I believe it goes for like 3 pages. So you can find that on there. You can use those charts. I'm going to show you how to use the charts. I'm going to show you how to use your calculator. Also show you how to do the formula. And you can pick whichever one you want to use as we go through and do them. Let's see, let's go back for a second. So binomial experiment, we talked about this. It's just an experiment that has 2 possible outcomes. That's why it's a binomial. 2 possible outcomes. So it can be simplified down to just success or failure. Not everything can be simplified down to this. So some of the stuff, and we'll probably have to go back over 4.1 before we take the test over chapter 4, because in 4.1 we were doing any kind of probability distribution. These are just now binomials. So all this stuff, all the stuff that we did in that first section, you could still do all that for all this stuff, but some of the things for this are easier if you use the rules for binomial, for a binomial experiment. Binomial experiment is repeated a fixed number of trials where each trial is independent of the other one. So they have to be independent. So I know one of the problems on the homework assignment you're going to have tonight says something about Ohio State Lottery, and they're drawing the balls out. And it asks if it's binomial or not. Well, it's not binomial because when one ball comes out, it doesn't go back in. It stays out. So each trial isn't independent. One trial, whatever number comes out, it's not going back in, so it's dependent on what happens the next time around. So you got to be able to decide if it's independent or dependent. There's always 2 possible outcomes. Again, success, failure. The probability of a success is the same for each trial. So that probability is the same every time. If we're doing something like shooting free throws, then the probability of making a free throw this time is the same as the probability of making a free throw the next time, which we know really isn't the case because as the game goes along, you get tireder. It's been proven that you don't make as many free throws and stuff, but for our situation here, we'd say that the probability is the same first quarter or last quarter. And we know Michael, if he's on the line with the game on the line,
They're losing.
his little rear end tightens up to like this, and my son was last night. They were
Maybe south.
They were up
They did.
He from JV. They were up by, where were they up? 1 point, I think, like 15 seconds ago, and he got fouled. 12 seconds to go or something, and he got fouled, got put on the line. I thought, yeah, he ain't making none of these.
Did you make them?
He made one of them.
Did they win?
Actually have to be one.
Yeah, they ended up winning. They won by 2. South had some young man, his number was 14 on the JV.
Like Chandler.
Thought he's,
Chandler Allred, yeah.
he thinks he's a basketball god or something, because after they're down 2, he got the ball back. The guard was bringing the ball up, and he went to the back court and took the ball from the guard, dribbled up court, and stood out front for 9 seconds.
They didn't win.
And then went this way and shot a long 3. I'm thinking, are you kidding me? You've been kicking their butt, driving the lane and stuff, and now you're going to throw up a long 3 just to try to be a hero instead of tying the game up at least.
He missed it.
But he missed it. But if his coach will let him do that, I guess, I don't know, if it's his daddy the coach or something, because if it,
He just,
is that sort of what he is? He thinks he's,
yeah, I mean, yeah, it's weird. Like, I'm really good friends with him and his family. And it's just like, yeah, I don't know.
His brother thinks he's a stud.
Yeah, his brother thinks he's like, number 2 on varsity.
I didn't stay to watch the varsity game, so. He just looked, you could just tell, and that annoyed me.
Yeah.
What annoyed me even more is that my son should have been guarding him at that point, and they had the shortest kid on our team guarding him at the end. I'm like, why? Random variable is your X. That random variable is, if we're dealing something like with making free throws, it's how many free throws you're going to make out of 5 or out of 10. So you might say, what's the probability that I make 3 out of 10? What's the probability that I make 4 out of 10? So on and so on. Number of times, N is the number of times that the trial is repeated. So these are the numbers you got to know. We got to be able to find N, we got to be able to find P, we got to be able to find Q, and X is what we're looking at for that certain thing each time. But there'll also be a list what X could possibly be, depending on what we're doing. Decide whether the experiment's a binomial experiment. I think we went over these, so we'll just do them real quickly. A certain surgical procedure has an 85% chance of a success. The doctor performs it 8 times. The random variable represents the number of successful surgeries. This is a binomial distribution because either the surgery is a success or it's a failure. So it is a binomial. The things you got to be able to pick out on these problems is you got to be able to pick out N. N is the total number of trials. How many trials are they doing in this case? 8. And you got to be able to pick out P, which is the probability. And you got to be careful with this, because sometimes they'll change the problem around and they'll say something stupid like, what's the probability that 3 of the surgeries are failures? Then you want to look at the failures instead of the successes. So you can't always just use those 2 words. So P stands for what we want to occur. Well, this time we want a successful surgery, so what's the probability that we get a success?
85%.
So we put it 0.85, then what would Q be?
0.15.
0.15. And then our list for our X's, how many successes could we have?
8.
Let's start at the other one.
0. 8.
So those are all the possible things. If it's just like this, list them out. If it's something stupid, and I shouldn't say stupid, if it's something really, really long, like if if he's doing 1,400 surgeries or something, yeah, I don't expect that you're gonna list all those out, all right? So you know, if it's 1,400, then you might do something like 0, 1, 2, ... all the way up to 1,400. What's wrong with it? So this is all the stuff that we just said. We could use a tree diagram. I did the wrong thing again. Jar contains 5 red marbles, 9 blue marbles, and 6 green marbles. You randomly select 3 marbles from the jar without replacement. Without replacement tells us right away, not the same chance of getting a marble the second time that you draw. So this can't be a binomial distribution. It's not a binomial experiment. This formula, please make sure you have this formula down. Everybody have it there somewhere?
Wait.
This second part, probably not going to use. We can plug all of this right here into our calculator as one thing if we decide to use the formula. And just do it. Using the chart, not too hard, but not everything's on the chart, so it doesn't always work. Using the formula is always going to work. It's not real difficult because you're going to touch most of it into your calculator anyway. Using the calculator, when I show you how to do that, it's not any easier or harder than using the formula there. So on this formula, even though it looks all crazy, you're going to figure out what n is right away in the problem. You're going to figure out what x is. You're going to figure out what p is. You're going to figure out what q is. And you're just going to plug into all those. And as we go through the rest of this year, Michael's off in La La Land. It's going to get harder. We're getting harder from here on out, Michael. All this stuff is pretty difficult. Huh? You don't like that? I want things to be easy.
I wish.
So just to give you pre-warning, and plus I know my first block class, boy, it seemed like senioritis had set in already. I'm thinking, wow, a long time to go. Microfracture knee surgery has 75% chance of success on patients with degenerative knees. The surgery is performed on 3 patients. Find the probability of surgery is successful on exactly 2 patients. So this time our N, what's our N this time? 3. What's our P? 0.75. What's our Q? 0.25. We want to find all that every time. Our X, our possible values that we could have if we have 3 that we're doing, how many successful surgeries could you have?
0, 1, 2, 3, 4.
Let's hope not, Isaac.
Hopefully it's not.
No, hopefully it's not 4.
Oh, yeah.
I didn't think you were going to say anything.
Got the doctor in there working on nobody, and might be something wrong with the doctor. So you got to be able to pick all that out, all that information out from the problem right away. You could make a tree diagram. Looks like this. We're probably not going to do that, so I'm going to skip over this real quick. Notice it's long, drawn out. Didn't like making tree diagrams from the beginning anyway, so we probably sure don't want to do it this way. Using the formula, probability that they wanted the probability that there was 2 successful out of the 3 surgeries. All you're doing with the formula, we found all these numbers, and why they made it 3/4 here instead of 0.75, I have no idea. why they make Q 1/4 instead of 0.25, I have no idea. But we're just plugging in those numbers. So you got C, 3 goes out front, you want 2 successful, times your P, which is 0.75, raised to the X power. X, what we want this time is 2, times your Q, which is 0.25, raised to the X minus N power, which is, or I'm sorry, the N minus X power, which is 3 minus 2. I would probably do this if you're using the formula. 99.9% of the time you can do that in your head. What's 3 minus 2? And then you can punch it into your calculator this way. If you want to get your calculator out, so I can explain to you how to punch it in. Then switch on me. You can punch it into your calculator this way. I'm not sure exactly how the calculator, and I really don't care to find out because it's just one extra button to push. If I push the parenthesis, so I push the parenthesis first, and then I push the 3 here. Then I go to the C, the combinations button, which is math. I didn't do it. No. Delete. Math. Sorry, mine was on the alphabet or something. And you go over to probability, go down to NCR, and then you put in the 2. And then close the parentheses, so we're just putting all that in parentheses, times 0.75, and use the little caret button to raise it to the second power. Then times 0.25, and then use the little caret button to raise it. We really don't need to raise it to the first power because it's just a 1, but anything else, raise it to the first power. And what's it come out to be? What'd you get?
0.42.
Anybody else get that? Because I got something different. I wonder what I did different.
Wait, so I have to put the combination in parentheses?
Yeah. Oh, I see what I did. I punched in 0.72 instead of 0.75.
We weren't wrong.
So what was it again?
0.421.
Something like that?
Oh, darn it.
So about 42% of the time, two of the three surgeries are going to be successful. That means when we're doing that, that means exactly 2. That doesn't count the times when there's all 3 of them are successful, right? Exactly 2 surgeries. So one of them is going to be a failure. That's the probability that that happens. So yeah, on that certain day, that surgeon has 2 successful surgeries and 1 failure. Results of a certain survey, U.S. adults consider air conditioning a necessity. This always kills me because everybody's got air conditioning just about now and never had air conditioning growing up.
I didn't
You know?
Not upstairs. I'm downstairs.
Our heat works.
My room is upstairs.
If 100 adults are randomly selected, what's the probability 75 considered a necessity? What's our N this time? 100. Now here, what's the probability this time?
67.
0.67. What's Q this time?
7? No. Oh.
0.33. Good. And then X. That's what we want to happen. What do we want to happen this time? How many people do we want to say it's a necessity?
So is it 0?
75. So our X this time is just 75. So we're just looking for the probability at 75. Now X could be 0, 1, 2, 3, all the way up to 100. But the one that we're looking at this time is just 75. We're making a probability distribution, a binomial distribution. Again, sometimes this book writes it sideways. Ours, I'd rather you write it this way, up and down, just because that's the way we've been doing everything all year long. I don't know why they changed for this certain chapter. But you'll notice here they put, this is that surgery, for the surgeries, they put the probability of that surgeon having 3 surgeries that day and none of them being successful was about 1.5%. Probability of one of them being successful and 2 of them being failures is about 14% of the time. 2 of them being successful and 1 of them being a failure is about 42%. And then 3 of them being successful and no failures, about 42%. And that's probably pretty good because if we got about 84% of them there that are going to be successful. You might want a little higher than that, I guess, if you were hiring that surgeon. In a survey of workers in the U.S., we're asked to name their expected sources of retirement income. Some workers who participated in the survey are randomly selected and asked whether they expect to rely on Social Security for retirement income. Create a binomial probability distribution for the number of workers who respond, who respond yes. So if we look at this, I don't know, can you guys read that? Which one of those
No,
is?
I can't read that.
Which one is Social Security? Fourth one over?
Yeah, that one I saw.
That one? So it's 25%. So what's our N gonna be this time?
7.
And what's our P? It's an ugly P, but
25%?
so 0.25. What's our Q then?
7.74.
0.75. And our X this time, what did it say? Oh, we didn't want an X this time. So our X this time is just 0 through 7. So that's all of them, because we're going to actually create a chart that has all this. So when you're creating this chart, this is what you're going to do. You're going to have this chart. We got X here, 0, 1, 2, 3, 4, 5, 6, 7, and these are a whole lot of fun. Because you're doing the same thing over and over again. So grab your calculators and we're going to do this real quick. And I'm going to show you how to do it using the formula. So if we plug it in, just like I showed you a little while ago, if I plug in parentheses, we want to do first, let's write the formula up here. It goes NC X times P to the X times Q to the N minus X, right? Is that formula right?
Yeah.
Yep. I'll send you guys down here in a sec.
For who? Microsoft.
So we have this.
Just gotta feel French. Gotta feel French.
Our N, we're going to stick in, make sure you're watching. Our X, we want to start off with 0 times P, which is 0.25, raised to the X power, which is 0, times Q, which is 0.75, N minus X, which is 7 minus 0. Now, if you're punching this into your calculator, trying to show you the easiest possible way to do it in your calculator. put in the parentheses, then put in the 7, go to math, go over to probability, down to NCR, put in 0, close the parenthesis. Sorry, I have a new calculator and it's, hit times 0.25 raised to the 0 power times 0.75 raised to the, what's 7 minus 0? 7 power. So now, once you have all that in your calculator, if we keep it in our calculator, because we're going to do this 7 different times, but if we keep all that in there, we can just go back into that formula and keep changing it. And we don't have to re-punch it in every single time. You hit equals, what'd you get?
0.133.
So 133, we'll say. That's probability of X.
Wait, when we're putting in, the point 0.75 raised to, okay, wait, never mind, I don't have to put -0. I guess, sorry.
Right, this you want to probably do before you
Yeah, it's okay.
punch it in. You want to just do it in your head, whatever it is. Now, if you do this on your calculator, you hit second, enter, it pulls that formula back up. All right, now we just go back up and we're going to change our numbers. So for 1, now we're plugging in where X is 1. So there's a 1 there. There's a 1 there.
So we're at 0?
Yep.
Where is 0 and 1?
And then 7 minus 1 is 6. And so now you just change all the stuff that you need to change there. The only bad thing about doing this way, you get in a hurry and you don't change the right thing. Like I already missed something in mine.
Wait, so it'll always be the zeros will be the X and the equation?
Yeah, it's always, we're just changing
Oh, okay, so like the, okay.
that X each time. So we're changing 1, 2, 3 different places. And actually that third place is something different because we're doing the subtraction in our head. Somebody help me out, what'd you get there?
0.33 or 0.311.
Anybody else get that?
Yeah.
Couple of you, or 1 or 2 of you do this one, do this one, do this one. Just spread them out. Some of you do the bottom ones down here, so we can go through and do it. So again, you just hit second
I'll do 6. I'm doing 7.
and change it,
I'll do 3.
and change, all you're changing each time is what's in the place of that X right there on all 3 of them, or on all 3 spots.
I did 6.
You got 6 already?
0.001.
4 is 0.057.
And 3 is 0.173.
Everybody doing 2?
What did I get?
You did it right.
I did it right?
Michael, what one are you doing?
I did 2, but I got the same answer if you want.
I'll do 7.
Okay, so I'll do 5.
Oh, look at you.
Oh.
Yeah, that's,
Did I mess it up or no?
5
Yeah.
is
Did you get an E?
point
I did 2.
011.
I got an E, or one of them. Times 10 to the negative whatever.
That?
Also,
Is that what you said?
I really got it right. or
What'd you
6.
get?
6.10 times 10 to the negative 5th. Is that what you got?
So what's that telling us?
You go back 5 spots from where it's at.
1, 2, 3, 4, 5. So what do I fill those spots in with?
0.
So it's
Point 0.
4 zeros and a 6.
Mhm.
Is that for 7?
Yep.
And what's that telling us?
It's really small change.
Oh, you got it.
Not much chance that
I'll do 2.
you're going to get exactly 7.
I did not get that.
Now, Michael was all worried, wouldn't say it because it was the same as this one.
No, I was like, I did
Yeah,
say
you
it.
were worried.
I did say it.
When you're doing this combinations, when you switch this stuff, if I do 2 here, it goes 7C2 times 0.25 to the second times 0.75 to 7 minus 2, which is 5. Remember, when you're doing those combinations, did we have times where it came out to be the same because it didn't switch stuff around any different? So sometimes they may come out to be the same. So this is our probability distribution. What should be true about all these probabilities? They should add up to 1 whole. Well, you do ours.
Here, I'll out. Do what? It's all on
You might.
It's fairly close. And at first looking at it, it looked like, it's not very close, but we got 1, 4, 7, 8, 9, so that's probably pretty close. Are those the answers that we got?
Yeah. No.
What they do on 7? They went ahead and did what to this?
Round.
Rounded it
They
up.
rounded up to just the one there at the end. Everything else looks pretty much the same, isn't it?
Yeah.
Yeah.
So this is our probability, again, our binomial probability distribution. Looks something like this. Now, if you make this probability distribution and they ask you problems, sometimes it's easy to make this, sometimes it's not real difficult. That wasn't real hard if we have a bunch of people doing it. It's not real hard to punch it in. So now if they ask you what's the probability that you get 3, you can just look right here and say 0.173. If they say what's the probability that you get more than 3, what can we do?
You would add 4 to 7.
You can just take all these and add them up. So if we have this probability distribution, we can answer all these problems. So sometimes it's good to have that. A survey indicates that 41% of women in the U.S. consider reading their favorite leisure time. You randomly select 4 U.S. women and ask them if reading is their favorite leisure time. Find the probability that at least 2 of them respond yes. So if we have this chart like this, it'd only be up to 4, but it says at least 2 of them, so we just take 2, 3, and 4 and add them all together. If we don't have it, then we got to figure out each of those. So we want to find the probability of 2, probability of 3, probability of 4, and we want to add them all up. And I did that right here, went ahead and punched into the formula and did it. Let's look at the chart. Now let's not look at the chart because it won't work 41%. I thought it said 40%. We add them all up and we get 54% chance that we get 2 or more. Notice on this one, they made their probability distribution. When you make your histogram, on your histogram, probability is always going to be on the side. When you put your probability over here, you're not going to be able to get down to like some of these 0.05. Some of them's going to be like on this one 0.006. We're not going to be able to show all that. So if you're making this, it might be something like we're on 1 right here. And you just color in a little bit right there. So, hey, there's something there, but it's not really enough that we can show it. All right, and that's sort of what they did here on 0. There's something there, but we can't make it small enough to show it. Notice, I would always probably go by 5%. each time. 5, 10, 15, 20, 25, 30, 35. Sometimes you might want to go by 10, depends on the problem. What's the shape of this graph?
It's like a building.
So we had, how many, the different shapes we had, what were they again?
Ooh, I have to look at it.
What's that called?
Symmetric.
Symmetric? Or it could be skewed right or skewed left. The other one that it could be, that we don't have very often, is when all of them are all the same size. We don't have that one very often. Anybody remember that name?
What's the store with?
Ooh. Hang on, yeah.
And I'm only asking because nobody remembered it last time I asked this
I
question.
have no clue.
Oh.
I'm not telling
Done it with. This is tricky.
you. No.
No. Straight line. I don't know.
We don't use it very often because most things don't always have the same probability. We'll come back to it. But these are the three that you need to remember. Symmetric, skewed left, and skewed right. Remember, skewed right means what? Skewed right means it has the tail to the right. Skewed left means there's a tail out to the left. If you didn't write this down last time, make sure you got it. This is on the calculator. This is how to do it using a calculator. And we're going to talk about this part down here at the bottom here in a second. Did we get this down last time?
Yeah, that's where we stopped.
This is where we stopped.
Yep.
So now this is, instead of using the calculator just to do the formula like we've been doing, which isn't real difficult, this is actually using the calculator and just punch it into the calculator. So we'll do a couple of problems. On this, you might want to write down, this says binomial PDF. This is if you're using if you're just finding one. If you're just finding the probability of one certain thing, one certain X. CDF we use when there's more than one. And that means, like, if you're saying, what's the probability that you make 4 or more free throws? What's the probability that you make 5 or less free throws? What's the probability that Jenna fouls more than 4 times?
100.
The ball.
1,000. Oh, leave me alone.
Oh, I didn't.
I forgot my jersey that game and coach was not
She touched the ball
good.
6 times, had 6 turnovers.
See what?
Touched the ball 6 times, had 6 turnovers.
That sounds about like my son. And he finally did listen to, I've been telling him all the time, hey, you can't dribble standing straight up. You gotta get your butt down, and he never listens, and his coach, one of the coaches pulled him off and goes, dribble up here, you gotta be down. And he finally did. I've been telling him that many, many
I
times.
hate dribbling. I hate like being a point guard. I hate it. Being a point guard is the worst.
So
Oh.
this is the woman one again. So let's do this, and I'll show you how to do it on the calculator. Let's just find everything real quick, and don't let me forget, I need to send you guys down there. What's N this time?
Where is it at?
41%. Or no, hold on, no, it's
4.
4.
4? So we're just asking 4 women. What's our P?
That's 40.
0.41. What's our Q then? 0.59. And then our X. Our X this time, X could be 0, 1, 2, 3, or 4. We want at least 2.
So 2 or 3.
So we're doing probability of 2, 3, 4. We're doing all those. And all we're going to do is we're going to find the probability of 2 plus the probability of 3 plus the probability of 4. And we got to find them all separately and then just add them all together. So on your calculator, to do this on your calculator, this is what you're going to do. To find each one separately, then you'll have to add them all together. Go to, you hit second, then the bars button. Does everybody see that? And you go down till you get to binomial PDF. Hit enter. And on your screen it pops up and it says binom PDF and it's got a parenthesis. Inside that parenthesis, you're going to put in N, comma, P, comma, X. So our N this time, what's our N?
4.
So we put in 4, comma, what's our P? 0.41, comma. Does everybody find the comma button?
Yes.
Then our X is going to change. We got to do this 3 separate times. Our X the first time is going to be 2. So punch in 2 and then close the parenthesis. Hit equals. What's it say?
0.351.
So that's the probability that you did all this and you got 2 women that said reading is their favorite leisure pastime. Now, to make it easier on you,
Go back and change.
hit second, enter. Let's get something different.
No, mine's just not working.
It's not working.
Keeps giving me an error. Error from me.
Want me to go back to it? So go second bars.
Yeah. Binomial PDF.
Got it.
4, comma, 0.41, comma. Oh, wait. I see what I did. I see exactly what I did. There's a point right here.
What kind
Okay.
So if you hit second, enter, it takes you back to the formula. And all you got to do is change, instead of 2, this time we want what? 3. So punch in 3 and hit enter. What's it tell you now?
0.162.
And we'll say 163, round that up. And then you do the same thing. Second, enter, and instead of 3, we want 4.
It's 0.028.
Then all we're going to do is add all 3 of those up, and that gives us a probability that either 2, 3, or 4 says it. So if you're getting into longer stuff, like if we wanted all of these probabilities, we could have just did them all. Instead of punching in all that, we could just punch in the N, the P, and the X each time. What'd it come out to be? 542? Let's go back. Don't want you to see that anyway, because then you'll get the answer to what you guys were asking me a second ago.
Oh, we
Mine
should
is
have
not
looked.
enough, so then- Are you ready?
Mhm.
Beautiful.
Uniform. I
That
couldn't
was,
find it
that
for a
was very
second.
slow. I had to like look at each one. I have mixed up.
I think we wrote these down last time.
Yep.
Yeah.
This is, if we're trying to find the mean, variance, or standard deviation, this only works for a binomial setup. This only works for a binomial setup. You can still use the formulas from section 1 to do all this stuff, but this is easier if it's binomial. I'll do this one. So this is just fine. That's not hard. N times P is the mean. N times P times Q is the variance.
Question mark, question mark.
I guess we have no.
Too easy.
Isaac, as soon as you and Jenna get this written down, we're gonna start on it. So you guys need to go down to, Mrs. Mike's cell. Please make sure you get the counseling that you need.
I didn't get counseling.
I know she's only got a little bit of time, but
You know what she did this morning? She told me to get 2 people out of the gym, and she forgot that the semester changed and that they weren't in the gym anymore. So I walked in there and asked for them, and he was like, "We don't have those people anymore."
and then you look dumb, didn't you?
Yeah, all of it. But I didn't tell Miss Mike, so I
It
don't hurt her
was
feelings.
bad.
Huh?
It was too much money.
Oh yeah.
Get your books out, calculators, and we'll start doing this together.
Maybe something a little lighter.
Some of them are really easy, so we'll probably skip some of the first few, because you can do them yourselves.
That's fair, but I'm getting too old. My hips are done for.
I
Yeah.
can pop my hip.
My hips are done for.
It's so satisfying.
Does everybody have the assignment written down?
Yes. Well, Michael? Oh!
That was so boxing one and then face hardening for no reason at all. What?
I thought we were winning. Yeah.
It's we're doing what we're doing. And if you just go let us keep doing what we're doing, so that you can do circle. It's close.
I know, poor guy.
Number 3, they want you to match up.
Wait.
We said this last time, I don't know why. I must have skipped over it this time. Match each given probability with the correct graph. Remember, on these, and we don't need to- the more
Our question.
times something happens, the better your graph's gonna look.
So like.
So that's what we're matching up here. So when we're looking at this, or actually for these first ones, those are for the other ones,
Because it's more accurate or because it's easier?
because it's more accurate. But that's for the second set, that's not for the first set. We had this last time. If your graph looks something like this, where it's skewed to the right, then that means your mean, or your probability, should say, is less than 50%.
So we know B is
If it's this way, where it's, sorry, that's sort of ugly, where it's skewed to the left, then the probability is greater than 50%. And if it's symmetric, something like that, where it's bell curve sort of, if I could draw, then the probability is equal to 50%. So for number 3, A, which probability goes with that? 0.50. For B, which one goes with that?
shoot, what's this here?
And for C, point what? That answer your question?
Yeah.
So it's.
Could we skip 4?
Yeah.
You guys can do that on your own?
Yeah.
Sure.
You want a second to do it, or you want?
Yeah.
Number 5, these are the ones I was thinking of. Number 5, as we're looking at that, the bigger N is, the better idea you got of what the actual graph looks like, and it just makes sense. I mean, if you go out and you survey 4 people, is that really going to tell you a whole lot? If you survey 400 people, that's gonna tell you more. You survey 4,000 people, that's gonna give you a better idea, so on and so on. So as we're looking at that on number 5, which end do you think goes along with that first one in part A? Is it- That's 12. That looks like it's giving you a better idea, right? How about for B? 4, that looks like the one that doesn't really tell you a whole lot. And then C? And then 6, same idea. Can we skip 6 then? Number 7.
Are you serious?
Thing you gotta switch back. Probably get a paper. On number 7, it says in each graph, which things are unusual. Remember, what's considered unusual?
Um,
Less than what?
less than, 0 or?
Boy, Joe always knew this.
Who's Joe? Joe Mama?
Joe Armstrong.
Joe Armstrong.
He literally tackled me on the bus one day because I was in the aisle and he was going to go to breakfast. And he literally just plowed through everybody.
So less than 5%. Anything that's less than 5% is unusual. So if we look at part A, which of our X's, the bottom, along the bottom, 0, 1, 2, 3, all the way up to wherever it ends at,
3. And
you
then
missed some.
we're on A, right? Yeah, it's at 3.
You missed some. What's before that?
0.
What else?
Where?
3 and 4.
Oh.
0, 1, 2,
Okay, alright,
3, because those all work, right?
yeah,
4. Any others?
no. No.
Yeah, there's another.
Oh, 11, 12.
Wait,
Will those be working or
I
not?
was too, but then it makes
That-
sense.
So is 11 less than 5? I can't see it.
Less than 5%.
No, 11 is
The
not.
question
Fine.
says.
Is it or is it?
No.
Identify the
I think it is,
unusual
isn't it?
values of X
No.
and histograms in exercise 5. So go back to
11? Oh,
Yeah,
wait, I'm thinking, yeah, it is.
Anything that's less than
And
5%
12 is also right.
is
12,
listed
13, 14,
listed out
15.
right
Now, be careful. Do we want to go out 13,
now.
14,
Is
15?
that-
No.
What was our end for that one? How many people did we actually survey?
So we did it for each graph. Yes.
So we only did it for 12, right?
I'm tweaking. I'm
So,
on the
so
wrong
12's got to be where we stop at because that's all the people we had.
Yeah.
Now, for part B, how many people did we have?
I was looking at A for 6.
4.
4, right? So our numbers can only be 0, 1, 2, 3, or 4.
And it's 0.
Any others?
No.
That's it.
Oh, yeah, I see what you're saying now.
How many people did we have on C?
We had
8.
8.
So we went 0 through 8 is what we're picking from.
0,
0, 1, 2.
3 is?
No.
No, it's not.
No, 0.
8.
8 is?
0, 1, 2, 8.
2, 8.
You're so small. I was looking at first, at the very first beginning, I was looking at 6 and
8's the same way. We skipping it.
8. 8
Yeah.
is the same, yeah. Addition, I'm having. Unless you can do it.
Says decide whether the experiment's a binomial experiment. If it is, identify a success. Specify the values of N, P, Q. So you're going to find N, P, and Q and list all the X's. So number 9. Cyanosis is a condition of having bluish skin due to insufficient oxygen in the blood. About 80% of babies born with cyanosis recover fully.
Isn't it like when you're like just a little bit?
A hospital is caring for 5 babies born with cyanosis. The random variable represents the number of babies that recover fully. Is it a binomial? Is there, can we separate it into just 2 categories?
Yeah.
Yeah, success or failure, or I don't guess it's success or failure, it's
Full recovery.
recovery or not recovery, right? So yes is binomial. Binomial. That answers the first question. It said identify a success. So what's a success this time?
80%.
Just what is a success? Just explain to me.
Oh.
The success is
Full
recovery.
recovered.
So baby recovers, something like that. I don't know however you want to write it. As well as I can understand it. Find N, P, and Q. So we want to find N, P, and Q. What's N?
5.
Is it 5? Is that right? I'm not looking back at the problem.
Yeah,
so
5 babies, yeah.
P,
Would be 80.
so 0.80. Q then,
0.20.
and then our possible values.
0, 7, 5.
Why not 6?
There's not, because there's only 5
That's 6
babies.
babies.
Not 6 babies. So could have 0 that fully recovered, could have 1, could have 2, could have 3, could have 4, could have 5.
Oh, it's
10 through 12, same things. Do we want to do them or do we want to skip over those?
Skip.
Skip over those? Everybody thinks they can handle those?
yeah.
13. 13 says find the mean, variance, and standard deviation. So we want the mean, variance. I should have made you guys tell me what each symbol is, since we seem to be having trouble with that. This is the standard deviation, right?
No, that's me.
All right.
I was looking down right.
Yeah. To find the mean for a binomial, mean is just n times p. Variance is n times p times q. And then standard deviation, which is just sigma, is the square root of n times p times q. If you do this, right, you can just have all this stuff in your calculator, and you can do the first one, then just go to the second one and do it right away, then the third one, same thing. What's n for number 13?
50.
What's p?
0.4.
What's that give us?
20.
Now, this should be in your calculator. 20 is in your calculator. And all you got to do is take it times Q. What's Q this time? P was 0.4. What's Q?
0.6.
So you just multiply it by 0.6. And what's that give you?
12.
And then you just got to take the square root of 12.
3.46.
Those are your 3 answers.
I think you can do the rest of the results.
You do 14, 15, 16.
Yeah.
Number 17. A little tougher now.
Answer guessing. I like guessing.
You're taking a multiple choice quiz that consists of 5 questions. Each question has 4 possible answers, only one of which is correct. To complete the quiz, you randomly guess the answer to each question. Find the probability of guessing, and then it gives us different things. First thing we want to do here is we want to find N, we want to find P, we want to find Q, so that we have them all. What's N this time? How many questions are we guessing on?
5.
What's the probability? Point what?
5 questions.
So 4 possible answers. 0.25. What's Q then? Sorry, I wrote those too close together. 0.75. And then our X, what's all the things X could be? How many could we get correct?
5.
Yeah, you guys are,
0, 0, 2.
you guys are optimistic, right?
Yeah.
You're guessing, I'm going the other way and thinking 0, 1, 2, 3, 4, or 5. Those are all our possible X's. Part A, they want the probability of what?
Exactly 3 answers.
So the probability we get 3 answers correct. If you're are we gonna use the calculator? I'll tell you what, let's get out the chart. Let's use the chart once, I'll show you how to do that.
Oh, darn it.
On the chart, because this one will work with the chart. Not everything will work with the chart because it doesn't have all the different percentages on there that could be. On the chart, you notice down the side it's got N. We want our N to be what this time? 5. So go down to where you see 5 over here on the left-hand side. We want our X to be what this time?
1, 2, 3, or 0, 1, 2, 3, 4.
No, exactly 3.
Oh,
We want 3 this time, right? So we go 5 and then go down to where you have the 3 in that column or in that rectangle there with the 5. And then what's our P?
0.25.
So we go over till we see 0.25
0.88.
and we match them up. What is it?
0.088.
0.088. Michael might not want to use the chart if he can't see. Because I can even see that 0.
Up to 0.25.
No, that's what I'm saying. Like, I thought it was 0.88. I just couldn't see the 0.
I know, that's what I'm saying. You might not want to use the chart because
So,
I could even see the 0. My eyes are horrible.
So at least 3
Oh my
answers.
gosh,
At
look at our rainbow.
So the next one says at least 3 answers. So it says at least 3. Is that what it says? So we want the probability of 3 plus the probability of 4 plus the probability of 5. So apparently you're wanting to pass, at least pass this, because that'd be a 60%, an 80%, and a 100%. So you're at least wanting to pass so you don't have to listen to your parents complain at you. We already did the probability of 3. That was 0.088. We can use the chart to find the probability of 4.
So,
Just go down to 5, down to 4, over to 25%. What's it say?
0.015.
0.015. Does everybody see that one? Now, for 5, we're just going to step 1 down in there. And what's it say?
Wait, what? 0.001.
0.001. And what are we going to do with all 3 of those? Add them up. Somebody help us out.
It's 5.
What'd you get?
.103.
10 what?
Wow.
4.
Wow.
So probability of you passing that test
It's like 10%.
is like 10% if you're just guessing.
This hurts.
Oh,
Next one, no.
what is that?
Letter C.
What? Is it
Over
even
there.
there? Did you hit him?
I don't know. I don't know.
Think I'm good?
Uh,
Here, see this
you
here?
got 2 C's right there now.
That's right. You guys figure it out. Letter C, what's letter C say?
Okay.
Letter C says less than 3 answers correct.
So we want probability
No way.
less than 3.
Probability. What?
Less than 3.
Now try to start.
Wait,
off
what's like?
exactly where
There was an extra C in there.
Okay.
So it got in my way. So if we want probability less than 3, what numbers are that?
0, 1, 2.
Ah, it's off the screen.
Yeah.
Sort of. I know.
You have to calibrate it or something now.
No, I just got to shut it down, and I don't want to shut it down because then
He's all sad now.
I'm in the bug.
Why don't you do it on the whiteboard?
Because he's recording. Bye guys. Sorry.
It'll come back. So let's just do it real quick. The easiest way to do it, we already did the probability of 3 or more. So all we want is whatever's left.
So we gotta go back.
So we're going back up the other way, but you don't have to use the chart anymore, because what do we know about all of them total? Well, they all total up to
1.
1.
One. I said
Did
that.
that come back on
So
or did
would
it
it be
not?
0.9?
Sort of.
Sort of?
Yeah. Let's wait for it to pop back up and then I'll.
Hey.
Well, let's just do it. What was our answer for part B?
0.104.
Emma with the explode.
So all we want for part C, we want probability of everything else. So we want probability of 0, 1, 2. We want all those. Well, we did all the others, so all we really got to do is take that answer from part B and subtract it from 1. What's that give you?
0.897.
You guys must have used the number that was already on your calculator, right?
I did the.
Oh, you did the chart? Because if I use this, what do I come up with if I do 1 minus that? Instead of 897, instead of 897, I come up with a 6 there. Same thing, sort of. So part C, you're finding all these, but you could just go back up here and subtract off this answer. The other thing I'm going to show you.
Wait, so subtract off that answer from.
Yeah.
From 1.
Because-
Because if you make the chart like we did earlier, it went all out of 1.
So if we had this, Michael, if we made our chart like Lily just said, we got 0, 1, 2, 3, 4, and 5, right?
Mhm.
We just found the probability
Of
of all those 3. That was
so
this.
Then, oh, okay, then you just subtract.
The only thing left are these 3. Well, all of them got total up to 1. So if we just take 1 minus that answer, that gives us all of this probability here. Now the other thing I'm going to show you on your calculator, if you're going down like this, so we're going 2 and down, on your calculator, grab your calculator and I'll show you this. If you go second bars and go down to the binomial stuff again, don't put in binomial PDF,
CDF.
go down to CDF. And what CDF does, CDF does everything from whatever number you put in for X and below. So if we wanted to do from 4 and down, but we didn't want to do all 5 of them separately, we could just punch it in our calculator using the CDF and it would do it. So if I go to CDF, I hit enter. I want to put in my N. My N this time is 5. My probability what was our probability? 0.25. Don't forget your commas.
And then,
And then we put in whatever number we want last, to include last, which this time is 2. And it gives us 0.896. Is that what we said?
we said 0.897, but that's.
Pretty close.
The revenue.
So PDF, the PDF one does one specific probability. The CDF does everything at and below. My pen mess it up. What time is this class in? Real quick, flip over to problem number 27. Problem 27. A lot harder problem here. Not really a lot harder, but hopefully you guys will help me out here and we'll get it done real quick. On problem 27, this sort of puts all of it together. 63% of adults say they are visiting the dentist less because of the economy. You randomly select 6 adults and ask them if they are visiting the dentist less because of the economy. What's our N?
So that's 6.
6. What's our P?
63.
What's our Q?
6.
Point
37.
37. And we could do our X's, but I'm going to do our X's in our little chart here. Because this is the first thing they want you to do. They want you to make the binomial distribution. What numbers are we going to list as our X's?
0,
0, 1, 2, 3, 4, 5, and 6. Now we can find each probability pretty quickly. You're going to go on your calculator, and some of you do, once we do one of them, some of you do, each one of them for us again so we can write them in sort of quick like we did over here. If I do 0, I'm going to hit second, bars, go down to the PDF, binomial PDF. Don't do that to me.
It's been messing up all, like, when you have.
Binomial PDF, N is 6, comma, 0.63, comma, and we'll do 0. Close the parenthesis, and I get point, no,
No.
I think you're doing
It's been messing up.
0.003. Is that right? Now, once you have that in there again, you can hit second, enter, and go back and just change your X. So we need X to be 1, 2, 3, 4, 5, and 6. So help me out, and somebody, a couple of you do each one of them. Tell me what you get, and so we can write them all in here and go quick.
6 is 0.6.
Don't tell me before the decimal, just after.
That's it.
625,
0, 65.
0, 625, so 063, is that right?
What?
Yes.
Okay.
Yeah.
What else?
I definitely did that right.
4?
Put it 4. Is that right?
5
That's what you
is
set it up.
0.220.
And that definitely says 06. Something.
Definitely says 0.32334.
I was talking about 6. 4. Let's say it.
Apparently I can't see, but it's
4 is 323.
Yeah, 0.323.
323?
Yeah.
Okay.
3 is 0.253. What did you do? 1, 2. 2 is 1, 1, 2. I'm under the last one.
was gonna start at the bottom and somebody.
Is it one, .026 for one?
So if we have this, the second thing they ask you to do is make a histogram. Just looking at these, if we change them to percentages, we got like 6%, 22, 32, 25, 11. So my percentages, I'm just gonna go by fives. So 0.05, 10, 0.15, 20, 25, 0.25, 0.25, 30, 0.35. That's our probability on this side. This side down here is the number of people that say the economy, so on and so on. I just don't have time to write it all out. We start at 0, 1, 2, 3, 4, 5, 6. My graph looks horrible. Notice for 0, 0 is like less than 1%, so I just put something like this down here. This little scribbly thing to show that something's there. 2.5%, so maybe some little bar like that. 11%, something about like that. 25%. 32%. Oops, went a little too far. 22%. And 6%. So about like that. That's our histogram. With your histogram, the other things they ask you is what shape is it? What shape does this look like?
Skewed left. Skewed left.
Skewed left. I might accept that. I might also say symmetric. It's not too bad, but one or the other probably of those. Skewed left, I can understand. It's got a tail maybe going that way. The other thing they ask you is what is considered unusual? Which of these numbers would be considered unusual to get?
0 and 1.
0 and 1 would be unusual. Finish up the rest of that.